Hey there, it's Wells. We're now going to look at this exercise 9I2d, which is this question here, 2d. Let's have a look. Find the y-coordinate and the gradient of the tangent at the point of the following. Okay, cool. So that tells me that you've got the x-coordinate, which is pi on 4, and you need to find the y value. Conveniently, they've already given you the equation to find the y value. So y has to equal to the cos squared of 2 times x, whatever x is. Okay. So in this case here, what you can see is we know that x is pi on 4. So in the next line, we can probably say here, find the cos squared of 2 times pi on 4. And therefore y must equal to cos squared of 2 times pi on 4. It just becomes pi on 2. So double over quarter becomes half. And to understand cos squared really just means the cos of pi on 2 and then square that. That's all it means. So cos of pi on 2, we know that in the unit circle, cos of pi on 2, the x value is 0 at 90 degrees. So I know this becomes 0 overall. So that tells me I've got my y coordinate. I've answered the first part. The second part wants me to find the gradient of the tangent at that point. So if you think about it, I don't know what the curve looks like, right? But say on a graph, if the graph looks like this, I'm just making it up, right? Then at x equals pi on 4, we just found, actually, I'm going to fix that because we now know that the y coordinate is 0. So that, let's just say it looks like this. Okay, I'm making it up. So at this point here, we found out that at pi on 4, the y value was 0. What you're trying to find out is the gradient, which if you imagine at pi on 4, if you could draw a tangent line that touches that curve only once, okay, at that point, at pi on 4, your goal is to find out what m is. Okay, and we know that to find the gradient at one point only, we can use the derivative. So your job now is to find out what is the derivative when x equals pi on 4. Okay, so our equation was y is equal to cos squared of 2x. And another way of writing that is y is equal to whatever cos of 2x is, and you're squaring that entire thing. Then your job now, when to find the derivative, you see delta y delta x is what you want. For me, when I look at that, to me is a chain rule problem there. You see, if we can replace this cos of 2x, if I can replace that and call that something else, so let's call that let u equal to cos of 2x, then it changes the problem and it makes it much easier. Now, y becomes, instead of cos of 2x squared, it becomes u squared. Okay, so have a think about what I was doing there. If you replace the cos of 2x with the letter u, well then the equation now becomes y equals u squared, which conveniently it makes it easier because if I were to find the derivative, which is delta y delta u, this makes it easy. We know it's 2u. But you see, the only reason why that would work easily is because I introduced a third variable to make it easier. This is where chain rule comes in. The idea is like, well, I actually wanted delta y delta x, but I couldn't get it. So we know in chain rule, they say, all right, well, you can introduce a third variable if you find delta y by delta u times delta u delta x. This is what chain rule is saying. And in some essence, it's essentially like saying delta u divided by delta u will cancel out if you're able to introduce a third variable and find this relationship. So we look back at what we have. I do have delta y delta u, which gives me this. And then conveniently, the relationship between u and x, I can actually find the derivative of that. I can use what I've learnt in this chapter. Delta u delta x is the result of derivative cos is negative sine of whatever the variable is, so negative sine of 2x. But then don't forget, you have to find the derivative of the inside as well. So finding the derivative of the inside is 2. So together, that's negative 2 sine of 2x. So that's my delta u delta x. Okay, technically I've just used a chain rule again. Okay, I just used another chain rule there. If that doesn't make sense, let me know and I can show you what I mean there, but I just did another chain rule. And so now I've got delta y delta u and I've got delta u delta x. Then putting them both together tells me that it is 2 times u multiplied to negative 2 sine of 2x. But don't forget, u was a made-up variable. So replacing what u was equal to, which is cos of 2x, that gives me 2 times cos of 2x multiplied to negative 2 sine of 2x, which conveniently gives me negative 4 cos of 2x times sine of 2x. Okay, and that should be my answer. But I'm just having a feeling they may have used a double angle. Let me just check the answer, whether they kept it as simple or did they simplify it. Let me see. This is 9, what is this? 9i, I think it was. Question, what was it again? Question, what did I go for? 2d. Oh, I still haven't answered the question. I found the derivative, but the question was asking me to find at x equals to pi on 4, what is the gradient of the tangent line? So remember, delta y delta x is the gradient. It does tell you the gradient for any point that you want. In our case, we want it when x equals pi on 4. So I need to sub pi on 4 into each and every one of these. So delta y delta x, which tells you the gradient. So remember, our goal was to find m, the gradient of that tangent line. So here you have negative 4 multiplied to cos of 2 times pi on 4 times sine of 2 times pi on 4. So together it's negative 4 times cos of pi on 2 times sine of pi on 2. And knowing your exact values, we know this is just 0 times 1, but anything times 0 is just 0. So we now know the gradient is 0, or the tangent line is 0 at pi on 4. So that tells me if the derivative is 0, it's a stationary point. So it could be a maximum or minimum at that point there. So the drawing that I made up doesn't make sense. It would have to be a nice horizontal line at the x-axis intercept. So either it's a maximum or a minimum right at that x-intercept, which is at pi on 4. Okay, but that's how you would answer that question 2D. That is essentially a series of chain rule. You can consider it as a double chain rule, but some of you may have learnt it as a formula, and then you would have got this step. You needed to make sure you found delta y delta u, put them both together. If you got up to this step, that's the derivative, but it doesn't tell you the gradient at the point. And so I substitute x equals pi on 4 and I get 0. Okay.